Alright, so this is going to be the solution to the 10th problem in the grind 75. This is a maximum subarray. So given an integer array of nums, we want to find the contiguous subarray with at least one number that has the largest sum, and we want to return the sum. So looking at this, the largest contiguous subarray with the contiguous subarray with the largest sum would be this subarray right here. And so while I was going through this problem, I noticed that negative numbers obviously do not positively contribute to the sum of the subarray. And I also knew that we wanted to do a sort of sliding window or two-pointer kind of approach to this, and that would yield an O of n solution. But I wasn't sure as to how to implement that properly. So I will actually work through this example right here, step by step, to see how that works. And we're going to just do that right now. So let me switch over to the illustration. So we're going to have two variables, a max sum and the current sum. The maximum sum has to be some value from the array because this is what we're actually going to return. And the current sum is going to be 0. We're always going to want it to try to float above 0 to be positive. But any time that it dips below, that means that we're going to move our front pointer, our imaginary front pointer, on. Because we're always going to be moving our back pointer forward, but anytime we have a value that takes us below 0, we're going to push our front pointer forward. Because we know we can do better than that. If there is ever a case where we have only negative numbers, then max sum will naturally just grab the single largest negative number, and that will be the largest subarray, which will just be that one negative number. So let's go through this step by step. So again, max sum is going to be equal to -2. Current sum is going to be equal to 0. Our pointer, we can think of it as our back pointer, is going to start here. Our current sum is 0. We're going to add this to our current sum, and we're going to see that it is now -2. And because this is the only value we've looked at so far, this is going to be our subarray right now. And we are just going to move on. So now we know that our current sum, so far the part of the array that we've looked at, is below 0, and we don't like that. So we are actually going to move automatically our pointer on, and we're going to do that by setting it equal to 0 and then adding the current value, which would be 1. So now our array is going to look like this, and our max is going to be updated appropriately because 1 is greater than the previous value of -2. So we're going to do that. Update this to 1. And 1 second. Just checking. Okay. Then we're going to move the pointer on again. See -3. -3 will take our sum down to -2, which is not beneficial. It will not help our max sum, so we're going to keep the max sum we have right here. And we are going to move our pointer on. Then, let's see, move our pointer on here. Because we know because our current sum right now, which is actually this right here, is -2, then we're going to reset our current sum to 0, which would technically move our pointer past this, or our subarray past this, and then we would add the current value we have, which is 4. and that will make our subarray this because our maximum is now 4. And we're going to reflect that here. And so this is good. So we'll now see a different side of this problem, which I sort of mentioned towards the beginning of when we flipped over to this illustration. We're going to move the pointer on to this value right here, -1, and we're going to notice it's actually going to take the sum down to 3. But our sum is still floating above 0, so we can safely include this in our subarray. Then we're going to move the pointer on. We're going to add it to the sum. It's 5 now. That's even better. So then we're going to update max. And we're going to move this along. And then we're going to move the pointer to 1, which is even greater. We're going to add it to our current sum. And we're going to see that max value, well, max sum will also have to be updated. So we're going to include that as well. And then we're going to move on here to -5, which will not actually take us below our threshold. So technically, we would update current sum down to 1, but max would not change. And max is what we were going to return. And current sum sort of represents this overarching subarray right here. And then we'd move the subarray on to 4 and see that that doesn't improve past the maximum sum, and so we'll keep our maximum sum as that. So we can kind of think as current sum as being kind of this underlying subarray right here on the bottom that I drew, and max sum being sort of the fixed one that is the best. So first off, it starts out like this. That's not very beneficial. So then we're going to move on to this because that's a positive number. And then because we have that positive number, we see that, which is not beneficial either, even though our current max was that one number right there. So then we move it on to here. This is great because it's a large positive number. We're going to continue on and continue on and basically all the way until the end, checking each time to against our current maximum to get the one that will be maximum overall. And that will yield this subarray right here. And let's actually look at the code implementation of this, which should be fairly clear at this point. So I'm going to switch these over, and we're going to look at what we do. So again, initialize our current sum to 0, and our maximum sum to some number has to be found in the array. And then we're going to iterate through our array, and if we ever get to a point that is less than 0, then we are going to want to update our current sum, which kind of represents our front pointer. And then we're going to add the value at the place we are currently at to our current sum. And if it is greater than our maximum, then we're going to update our maximum accordingly. And that is the solution to the maximum subarray problem.